Okay. See, everything that we study in relations and functions, they depend on sets, okay, our understanding of sets. So here we have two sets, A and B. Maybe this is also a good idea to maybe give some different names to these sets. Okay, so sometimes people say that A, you're beginning from A and then trying to go to B, right? It's not necessary, but it looks like that, right? It really looks like that. You are mapping an element in set A to an element in set B. So you are doing some kind of mapping. Okay, you're making some kind of connection here. So for those reasons, maybe it is a helpful idea to think A as the source. Okay, so A is a source set. You can say it is a source set. And B is a target set. You can say that. You can actually use some other words. Okay, so you can also say that maybe your A is kind of input space. Okay, so you can say it is an input space because you are kind of working on elements in your set A and then trying to maybe generate elements in set B. So you can say that B is your output space. Okay, so these ideas you can carry in your head. For example, so what is happening here? We are taking A1. Okay, it is connected with B1 and it is also connected with B2. Okay, so you're relating A with B1 and B2. So here, we don't know what these A1s, B1s, B2s are because when we study things in mathematics, okay, we slowly study things abstractly. Okay, now अभी मैं वैसा बोलूंगा तो थोड़ा सा डिफिकल्ट रहेगा समझने में, बट एक ऐसा समझो कि whatever you learn in mathematics, okay, is learned in a way that you can apply it in many areas. ये बहुत बड़ा एडवांटेज है मैथ्स का. ओके, सो जैसे हम ये सब सेट्स सीख रहे हैं. ओके, सेट्स सीखने के बाद we have been learning relations. Okay, now relations सीखने के बाद today we will start a very important topic called functions. Okay, so थोड़ा slow scale में, okay, I think small scale में we study functions. Now functions एक ऐसा चीज है कि you use them everywhere. Okay, both in all types of sciences. Okay, especially when, let's say, we start discussing physics, let's say, you will see that we always work with something, some function or the other. Okay, and maybe later on you get an idea to study economics, suppose. Okay, आपको economics पढ़ना होगा, वहाँ पर भी function होते हैं. You are trying to study how one thing depends on the other. Okay, so whenever you study any such thing, you have to study functions. Okay, now ऐसा है कि for all this study आपका sets जो है एक base बनता है ना. So this kind of foundation है. You have to understand sets एक foundation है. उस foundation के ऊपर you are trying to build and say कि okay, you are trying to understand relations. And we are not done with relations yet. Okay, so there's so many things to learn. Okay, and then on top of that you build functions. And when you study functions, there are various types of functions. Okay, and then we will study like one by one. Okay, as many as possible. So I say build kar rahe. So in this case, ये जो relation होता है, the one that we are trying to study, relation is some kind of connection, some kind of meaningful connection between elements in set A to elements in set B. Okay, so you have set A and set B. Like, I think, remember I gave that example that, okay, so this could be set A could include, the drinks that you have. Okay, so the drinks that you prefer. And then maybe this is, let's say, snack items that you have along with the drinks. So for example, let's say A1 may be tea. Okay, so while I have tea, maybe sometimes I like to, what do you say? Sometimes I like Parle biscuits. Okay, so I have a connection with tea and Parle biscuits, right? Do you like Parle biscuits with tea? Have you tried?
Yes, sir.
Yeah, I like the taste actually. Okay. Harsha, try nahi kiya?
Which one, sir?
Parle biscuits with tea, chai. No, it pairs well. And in Hyderabad,
No,
I like
sir, I
one
don't
more
know.
thing. B2, I can also have Usmania biscuits. They are also great. So maybe, let's say the set B is a set of snacks, right? Set A is set of drinks. So I am having a relation. I'm having a meaningful connection, right? Now this is maybe it reflects my preferences maybe. Okay, so somebody else's preferences might be different. Okay, so they can be understood differently. So your starting set, you can say A is the source set or the input space, and B you can call it as the target or the output space, right? And then when it comes to domain, range, and codomain, these are the three terms that are very important to understand. And then after a few classes you will definitely understand this, because we'll be working on many problems based on these three concepts. Now, what is a domain? Okay, so what is a domain? Domain is the list of elements in the source set. Okay, so the list of elements in the source set which have a connection with the elements in the target set. Okay, so those are the so the set of those elements is the domain. Harsha, you understand? So here, if you
Yes,
see,
sir.
I'm saying domain is what I have connected only A1, A2, right? I did not connect A3. So A3 will not be part of the domain. Okay, will not be part of the domain. So if you, let's say, if you happen to think set A as the source set, or maybe the beginning set, you're actually starting from there, suppose. And then you're connecting the elements in set A to elements in set B. There are elements which are left out, not connected. Okay, so they're not relating. Maybe A3, I don't know, A3 is like Karela juice. Okay, I don't know, maybe no snack item goes with Karela juice, or maybe I don't like Karela juice. Okay, so I left it out. Do you like Karela juice? I don't know. I had once, but I did not like it. Okay, so the idea is, if you have some element which is not connected, it cannot be part of your domain. Domain is a set of elements in the source set which are connected with the elements in the target set. Okay, so that is one. Now, codomain is very simple actually. Codomain is all the elements in your target set. Okay, whether they are connected or not, it doesn't matter. Okay, so all of this B1, B2, B3, B4. Okay, so you can imagine, like, B2 could be some snack item. Maybe I will put some examples. Okay, so B2 could be chips. Okay, B2 could be chips. B3 could be samosa. okay, and B4 could be a burger, okay. And we'll take examples. A1 is tea, so this is coffee. And what else can we say? Maybe A3 is like juice, okay. You're okay? And then range is what? Range is, you are now thinking in terms of the target space, okay. So the target set, all the elements which are again connected, okay. So B1, B2, B3, they are connected to some element in set A. So the set of those elements become range, okay. So guys,
sir.
I'll pause here for a minute, reflect on it, see if you understand this. Okay. Okay, Om, you want to say that again?
Yes, sir. Sir, in the target set, sir, those elements which are connected with the input space source, sir.
Right.
So those are called range, right, sir?
Yes. So the set of those elements, absolutely right. Okay. So what you're saying is right. The set of elements in the target set, which are connected with the elements in the source set, become the range. Very good. Yes. Okay. So do we understand this now? So you have range, domain, and then codomain. Harsha, are you okay? Is he there now? Oh, we lost him, I think, Om. Okay, Harsha, now make sure you understood these three terms, domain, range, and codomain. Are you okay?
Yes, sir.
Have questions?
No, sir. Sir, we can also like codomain is domain union range, right?
No. Codomain may, it is not union of domain and range. See, if you take union of domain and range, you will get elements in set A also.
Yes, sir.
See, these elements A1, A2, A1, A2, they are not there in set B, right? Your set B is codomain. So you're not taking union of domain and range.
Then now, what would be the codomain, sir?
Codomain, Harsha, the set B itself is called the codomain.
Okay.
See, I know that the maybe he is confusing us. Codomain is the set B itself. Okay, you can say the target set को ही हम codomain बोलते हैं. You understand?
Yes.
उस codomain में the elements which are connected with elements in set A will form range. Understand? So you are not taking, let's say, the union of domain and range. No. Clear?
Yes, sir.
Okay.
So in that code domain, B4 will be also included, right?
Yeah, B4 will be included. It is the entire set B. Yes. If you take look at range may B4 is not there because it is not connected to anybody in set A. If you connect, let's say, if you connect, suppose you would like to have, let's say, burger whenever you drink, let's say, juice. Okay, if A3 is connected to B4, then your range will become codomain. You understand? Harsha, are you okay?
Yes.
So this is the idea.
Yes, sir.
So let's look at maybe let's look at the examples that we saw earlier. Okay. And again, that is why this statement I wrote, your range is actually subset of codomain. Okay. So the elements in the range and codomain are in your target set only, set B. So remember this example that we saw. Okay, so if you take set A has natural numbers from 1 to 10. So the relation from A to A, which is also called relation on A. Because here, what is happening? When you have the same set as the source and the target, okay, so Harsha, in this case, maybe you can say union वैसा कुछ हो रहा है, okay, because you are actually mapping elements in the set to the elements in the same set, okay, and the connection you're trying to build is based on this rule, okay, so you are saying 2x minus y equal to 0, or you can say y equal to 2x. And then let's look at this again, okay. So range will, the relation will be what? R is the relation. So if you take element 1, okay, if x is 1, maybe I'll write down here. If x is 1, because we are trying to do y equal to 2x here, y will become 2. So that is why you have that element in the set, okay. And then if x is 2, your y will become 4. So that is there. If x is 3, y becomes 6. So that is there. X is 4, y becomes 8. Okay, so that is also there. If x is 5, y is 10. So that is there. If x is 6, y will become 12. Here, I am actually forcing my source set and the target set to be same. Okay, I'm connecting elements in the same set, right? So for 6 to be connected, okay, for 6 to be connected, I need to have 12. But I don't have 12 in my target set because target set is also A. Okay, my set has only the first 10 natural numbers. So I cannot have a connection from 6 to any number. So that is why you don't have an ordered pair with first element 6. So similarly, you cannot have an ordered pair with first element starting from, let's say, 7, 8, and so on. Okay. That is why here, what is the range? If you look at the range is for this relation, the range will be this. So these are the elements in the target set connected. The domain will be these. Okay, so this is your domain. Now, when it comes to codomain, you are taking the entire target set. So this entire thing becomes codomain. Clear, Harsha?
Yes, sir.
Okay, so domain is those, you can say, input elements. Range is your output elements. You can say, in a way, if you want to say, you can also say this, okay, because in maths, we always try to show some dependency of y on x. Okay, so this is something that we do a lot. Okay, it is certainly helpful for us to think x values as the domain. You understand? So your x values, you can say your x values are your domain. You can say y values are your range. And then usually not all y values are connected with x values. Okay, so your codomain may contain few elements which are not connected. So for example, in this case, the elements which are not connected are 6, 7, 8, 9, and 10. So they are not connected. They are, oh, sorry, what did they are not connected. Sorry. I made a mistake. Which are not connected? In the codomain, 6, 7, 9, those odd numbers are not connected. I think, sorry, my mistake. Odd numbers are not connected, right? So these are not connected. 1, 3, 5, 7, and 9. They are not connected. So codomain is basically the target set. You can say this is the target set. Yeah, Harsha, you're saying something?
Never mind.
Uh,
I just
Harsha, you want to say that again? I think there's some
no, sir, nothing,
problem
nothing,
connection.
nothing.
Uh,
That's nothing.
Harsha, I think there is maybe a poor connection. Om, did you
So
catch
it's
what he's saying?
No, sir. I couldn't say.
Okay. Harsha, maybe you want to say that again, what you're saying?
no, sir, it's nothing. Sir.
It's fine? Okay, take it.
Nothing.
So maybe we'll revisit one more example that we saw so that we solidify this understanding, okay? Okay, I think, yeah. I think I'll give one more example, guys, before we move on, okay? Just give me a minute. Okay, so this time, we'll say, let's say, I'm using these words liberally, okay? So source and then target, let's say. So I have set A. Let's say I'll take numbers like 1, 4, and then 9, and then 25. Okay, and then set B, I have 1, 2, 3, 4, 5, 6, 7. I'm just, okay. Now I have a relation, I'm defining a relation, which is the set of all ordered pairs. So this relation is going from A to B. Okay, so relation is from A to B, set of all ordered pairs x comma y such that, okay, so such that x is square of y and x and x belongs to A and y belongs to B. Okay, so this is the relation. Okay, now here if I list down the elements of my relation, okay, if I list them down, okay, so if I list them down, what do I get? Now if I take x as 1, okay, so 1 can easily be connected with 1, so 1 square, right? So you have that here, so 1 comma 1, and then if I take 4,
I think x belongs to B and y belongs to A.
x belongs to
B, sir.
no, I am defining it this way, Harsha. I am saying x is y square. I can do that.
Okay.
The way I'm
But-
defining is I'm saying x is y square. So
But there
you
is
don't
no
have
like
to, you don't have
16
to
or
think that what you are squaring is your input. You don't have to do that. Okay. Maybe we are trying to get a square root. We don't know. So if x is 4, what is it connected with?
none.
Harsha, what is it connected with?
It is connected with none, sir.
4 is connected with?
So it is connected with none, sir, because there is no 16.
Array, no. Harsha, y square is x. See. I am squaring this to get this. I'm squaring y value to get x value.
Okay.
See,
So then it would be 2.
it would be 2. Harsha, you understand?
Okay.
I'm
Yes, sir,
squaring y. You got it? So
Yeah.
now, Harsha, tell me, if x is 9, what is y? X is?
3, sir.
Very good.
3.
Okay. Now, if x is 25, what is y?
5, sir. 5.
5. Okay. Now suppose I'll try to add one more element in A. So suppose if I add the element 37, okay, so if I add 37, now can 37 be related with any element in B?
No, sir.
No, right? So I'll have to leave it out. I cannot make it part of the set. So that means from the source set, I'm leaving it here. And then here, from here, what am I leaving? I am leaving 4, I'm leaving 6, I'm leaving 7. So now what is my, let's say the easiest thing is your codomain, okay? So your codomain is your target set, simple. Okay, इस पे ज़्यादा सोचने का नहीं. So target is just B. So you have all these 1, 2, 3, 4, 5, 6, 7. Now let's look at domain. What is domain? Domain is the set of elements in your source set which are connected. So now tell me what are the domain. So these are the domains, right? Okay, so Harsha, do you want to list the elements in the domain? Okay, I think he has poor connection again. Om, you want to list the elements in domain?
Yes, sir.
Yes.
Okay, 1.
1, 4,
Okay,
9,
okay,
25.
25. Very good. Okay, can you list the elements in range? Now, range are the ones which are only connected in target set, from target set. So what are the elements in range?
1, 2, 3, 4, 5.
No, is 4 connected?
So no, sir. No.
So only this. You guys understand?
Yes, sir.
Yes, yeah.
Yeah. So this is how you should understand. Okay. Again, I'm going to pause here before we move on to the second part of the discussion. So guys, will do one thing. Okay. Okay, guys, one thing. So don't worry too much about if things are not like going easy. It's okay, because to be honest with you, मैंने भी तब पहली बार ये relations functions पढ़ा था. Concept of domain, codomain, range मेरा बेजा फ्राई हो जाता था. इट्स लाइक थोड़ा सा माइनर डिफरेंसेस है ना, तो उससे मेरे को भी वो टाइम में मतलब तब मैं पहले बार ये समझा था, समझता ही नहीं था. ओके, बट ट्रस्ट मी ऑन वन थिंग, आप ऐसा प्रॉब्लम्स करते जाओगे, डिफरेंट डिफरेंट प्रॉब्लम्स ऐसे करते जाओगे, समझते जाओगे ना, एक थोड़े दिन में यू विल बी कंफर्टेबल. ओके, एंड देन यू विल स्टार्ट डूइंग गुड लेवल ऑफ प्रॉब्लम. So no tensions. Okay. Okay, so we'll look at the second part of this relations and functions, and then mostly we will be understanding functions today. Okay, now this is how you want to look at things. Everything is based on a set. Okay, अपना foundation क्या है? Set है. And then set के बाद we are taking two sets. We are saying कि we have set A and set B, and then ये दोनों को relate कर. So in that process, we had all those ordered pairs, right? And the set of all possible ordered pairs from set A to set B a Cartesian product. And then we may not be interested in all those elements. Okay, so they can be many, बहुत सारे हो सकते हैं ना. Cartesian product अगर ले लिया आप A to B, बहुत सारे elements हो सकते हैं. For example, अगर आप set A में 10 elements है, set B में 10 elements है, 100 elements होते हैं. Okay, so with only few elements you have so many elements. We may not be interested in all those. Okay, and then we have this idea of relation. Okay, so Cartesian product के elements में से if you take only some of them which have some meaning, that forms the relation. It is again a set. Now relation के ऊपर एक functions है, मतलब यहाँ पर क्या है, we are trying to refine, you can say कि हम sets की बात कर रहे हैं, everything is actually a set, but yeah, we are placing let's say maybe you can say more restrictions, ऐसा भी बोल सकते हो, या more rules लगा रहे, but in a good way. Okay, so they are there to help us. Okay, so they're there to help us. So if you start with this set, okay, so ये जो oval है, it is a set. Now this is a Cartesian product. Okay, so you are saying this is the set of all ordered pairs. Cartesian product क्या है? It's basically if you have a Cartesian product from A to B. Where is this? Okay, so if you have a Cartesian product, अगर ये Cartesian product A to B है, and then this will have set of all ordered pairs. वो सारे ordered pairs में हमें जरूरत कितना है, we don't know, depending on the situation, right? यहाँ पर हम क्या abstractly पढ़ रहे हैं सब चीजें. Okay, when you apply it to various subjects, आपको थोड़ा और मजा आएगा. Okay, so that is one thing for sure. Okay, so here we are saying, okay, you have a set. This can be a huge set. हमें उससे सारे elements से मतलब नहीं है. We may not require all those elements. So उसमें से we are taking a subset. Okay, so this subset is a relation. Okay, so the relation is let's say वो एक black set है, उसमें से एक और green set ऐसा, मतलब you can just understand. And then now out of this relation we have another set. Okay, so that is what we will study. So this is the function. Okay, now it's important to understand, yeah, we will see a lot of algebra वगैरह, but आपको क्या है, you have to associate meaning with that algebra. Okay, आप ऐसा blindly when you look at the algebra, आप खाली manipulation जैसा मत सोचो. Okay, maths is not like, you're not trying to just manipulate, or you're not just trying to substitute. Okay, so you try to associate meaning. Okay, so this is a function. Now let's understand. Okay, अभी हम समझने की कोशिश करेंगे. We'll go slowly, guys. Okay, this is an important session. What are we saying here? A relation. Okay, so we are giving a name F from an empty set A to another, sorry, not empty. I think I said empty. It is a non-empty set A to a non-empty set B. Again, we are dealing in sets. So you have a source set, you have a target set. Okay, so set A, set B, and you have a relation from A to B. Now this relation is called a function. Okay, so क्या है, a function is built on relation now. Okay, so function is built on relation, but if it has to be called a function, there are conditions. So ये if आ गया अभी. Okay, so हमें ये if को समझना पड़ेगा. I will try to repeat these things. I think थोड़ा ज़्यादा ही repeat करूँगा आज, so that you get the idea of function. Because अगर ये function हमें अच्छी तरह समझ में आ जाता है, so later on हमें दूसरे चीजें समझने में, दूसरे चीजें समझने में easy होगा. जैसे हम इसके बाद we will study various types of functions. Okay, जैसे there are simple functions. There are slightly simple functions like exponential functions, logarithm functions, trigonometric functions, and then you can get into slightly थोड़े खतरनाक functions भी हो सकते हैं. वो थोड़ा हम समझेंगे धीरे, बट फंक्शन समझना इंपॉर्टेंट है पहले. सो ये इफ की कहानी क्या है? सो वी वांट टू लुक एट द कंडीशंस हियर. ओके, सो यू हैव एवरी एलिमेंट ऑफ ए. ओके, सो यहाँ पर क्या है, रिलेशन में we are not interested in all elements. Remember, we can actually leave out certain elements in relation, but when it comes to function, हम ऐसा नहीं कर सकते. So we have to go with every element of A. So we have to take every element of A has one and only one image in set B. Now, ये image means what? Image is like you're just making a connection. Okay, so you're associating an element in A to an element in B. But remember, I think when I gave examples of relation, वो जो chai biscuit वाला ही example ले लो. Okay, T is an element in set A, and in set B, I have two elements, one Parle biscuit, the other Usmania biscuit. Okay, I can, let's say, eat Parle biscuit while I sip on tea, or I can eat Usmania biscuit while I sip on tea. Okay, so I can associate an element in A with these two elements in set B. But in function, you cannot do that. Okay, so if you are calling a relation a function, you cannot do that. You can only associate T with either Parle biscuit or T with Usmania biscuit. Okay, so this is the restriction. Okay, this is very, very important. Okay, so let us go through this slide again. So we are saying a relation itself is a function. Okay, so we can say function is a type of relation, but उसको additional conditions आ गए. Okay, थोड़े requirements बढ़ गए. Relation, okay, from a non-empty set. ये non-empty होना important है. A non-empty set A to another non-empty set B is called a function if every element of A. अभी सारे elements source के associate करना पड़ेगा, but आपको कैसा करना पड़ेगा? एक ही एलिमेंट के साथ आप एसोसिएट कर सकते हो. ओके, सो वन एंड ओनली वन इमेज इन सेट बी. ओके, सो लेट्स मूव ऑन. नाउ दिस इज अनदर वे ऑफ थिंकिंग अबाउट इट. ओके, सो योर सेट इज लाइक अ मैथमेटिकल मिशन. ओके, एक मिशन जैसा है. सो कैसे, मतलब मे बी आई थिंक एक ऐसा rough mission का diagram ले लेते हैं. Okay, so you have, sorry, 1 second. So I don't know, maybe I'm calling this a mission. Okay, guys. So यहाँ से आपको input डाले जाएगा. So you have input, and then यहाँ से आपको output आएगा. ऐसा एक mission है, mathematical mission है. And then उसके अंदर वो कुछ भी करेगा. So this function does something. ओके, मे बी आपका फंक्शन बहुत सिंपल फंक्शन हो सकता है, मे बी स्क्वायर करके दे रहा होगा. ओके, सो अगर आप नंबर 1 दे देते हो, सो इट गेट्स स्क्वेयर्ड एंड देन यू गेट 1. इफ यू गिव 2, इट गेट्स स्क्वेयर्ड एंड देन यू गेट 4. सो सम काइंड ऑफ मैथमेटिकल मशीन. ओके, सो अ मैथमेटिकल, यू कैन से अ फंक्शन इज अ मैथमेटिकल मशीन. इट टेक्स एन एलिमेंट. ओके, सो उस एलिमेंट को आप इनपुट बोल सकते हो. ओके, from set A and transforms into an element in B. So ये मैं निकाल देता हूँ जो लिखा है. Let me remove that. Let me remove so that you see the entire sentence. Okay, so you keep that picture in mind, machine wala. Okay, so maybe I'll try to draw it here. Okay, I'll try to draw it here again, so that I practice my drawing skills. Okay, so I say beta. So ये machine है. Okay, so this is a machine. So इस machine में you put some input, आपको कुछ output है. Okay, मतलब it's not, you can say गेहूं दाला आटा आया type of machine है, but ये mathematical machine. Okay, so you are giving some input, you are getting some output. Now your input is an element in set A, and the output is from element in set B. But if you are saying your function is from A to B, okay, अगर आपका function A to B है तो वैसा बोलोगे. अगर आपका function B to A है तो B becomes your input and A becomes your output. I think that is understandable. Guys, are you
Yes,
getting the idea of function?
Yes, sir.
Yes, sir.
Okay. Yeah. So let's move on. I think इसको थोड़ा और repeat करेंगे so that you get the idea. Okay. Now ये एक mission, it's a very consistent mission है और भी. Okay. So ये भी समझना पड़ेगा आपको. This is a consistent mission. So कैसा? It produces an output for every input. आपको जो source set है, every element is associated. So in a relation, that was not mandatory. Okay, so optional था. आप थोड़े elements आप leave out कर सकते हो. But when it comes to function, आप कोई भी element को आप छोड़ नहीं सकते. So you cannot leave out. So it actually produces output for every input. So all inputs are, all elements in the input set are included. Now what else? Other thing is, if you have a specific input, it has a unique output. Okay, so it has a unique output. Suppose, I mean, आजकल तो TVs का थोड़ा सा बदल गया, बहुत बदल गया है. But imagine, I think mobile phone ही ले लेते हैं हम. Okay, so mobile phone is giving us some functionality. Let's say आप कोई Harsha is trying to call Om. Okay, so he dials Om number. It is going to make a connection to Om only, right? And Harsha thinks that okay, he should talk to Gautam. So he dials that number. It only connects to Gautam, right? You guys understand?
Yes.
So mobile is giving you a functionality. It is consistent, na? So when you dial the same number, suppose today it is connecting to person A, and then tomorrow it is connecting to person B, then there is some gadbad. You understand? There is some malfunction. So then you say there is some malfunction, right? We use that word malfunction. Are you getting?
Yes.
So that is why when you say function, a specific input will have a unique output. Getting? Are we okay
Yes.
here? Yeah. Now one more small thing here. One more small thing here. If you have two inputs, okay, if you have two inputs, the output can be same. Maybe, let's say Gautam has two mobile numbers, let's say. Those two mobile numbers are associated with Gautam. You dial either of them, transferring a call towards Gautam. You understand? I know Gautam is not there. We are using his example, but you understand, guys? Yeah.
Yes,
So,
sir.
yeah. So two inputs can map to one output. Okay, but the same input cannot map to two different outputs. Okay. So, आपने एक number दबा दिया. The call today went to Gautam. Okay. So let's say tomorrow, I don't know, it went to Trump. It is not accepted. Okay. You're getting?
Yes.
So here, so two or more inputs can get transformed into the same output. Okay. So again, this is, I'm trying to repeat this idea. So what are we saying? Relation is a function. Not all relations are functions, but a function is a relation, isn't it? So a relation F from a non-empty set A to a non-empty set B, it gets promoted. Okay. So we are saying now a relation is getting promoted. Okay. A relation gets promoted to a function under the following conditions. So what are the conditions? Number one, because we are using all the elements of set A. Now kya hoga? In the earlier examples, your domain need not be your source set A, but if your relation is a function, your domain must be your source set. Okay, so if you have a function from A to B, so this is how you write A to B, then your domain is A, period. So that is the first condition, because you must use all the inputs. Okay. Second, no two distinct ordered pairs have the same first element. So it is like saying that आपका input तो same है, but you are getting different outputs. That is not allowed. You're getting, guys? No two distinct ordered pairs have the same first element. Okay, so in your function, if you have elements like this, suppose I have 2 and then 4, and then I have 2 associated with 8. This is not allowed. Okay, so this is not allowed because your input is 2. Sometimes your output is 4 and some other time it is 8. That is not allowed. Clear? Guys, I'll pause here for a few seconds. You guys understand? We'll take examples. I think we'll first understand it conceptually.
Yes, sir.
Yeah, okay. So let's move on. Okay, so थोड़ा सा notations ये समझना important है. So ऐसा लिखते हैं. So let f be a function from A to B, and then if you take an ordered pair, okay. So if you take an ordered pair which belongs to the function, okay. Now, a few terms that we need to understand. You denote the function like this, okay. So f likhte ho, and then you have a colon, and then the source is A, target is B. वो दिखाने के लिए, so to show that you show an arrow, okay. So this arrow is indicating that you are actually going from A to B. So the elements in A are connected with elements in B, providing those two conditions are valid. Okay, now B is called the image of A under this function. Okay, so B को क्या बोलते हैं हम? B is the image of A, and A is called pre-image. Okay, so these are the terms that you need to keep in mind. So एक image है and एक pre-image. So A is the pre-image of B, and then B is the image of A. And then you also write f of A as B. Okay, so let me give an example. So suppose your function is, let's say, x square. Okay, your function is x square, and then your set A has like 1 and 2, and then set B has, let's say, 4 and 9, and then 8, and then 1, suppose. Then you write f of 1 as 1 square, 1, f of 2 as 2 square, which is 4. Okay, so you have that bracket, and then whatever input you're providing, you provide there. And then it does what it has to do. If it has to square, it will square. It depends on the function definition. Okay, so this can vary. Okay, I think this is clear, right? Let's move on. Okay, so here, let's take an example here. We have set A, and then we are defining a relation on set A. So that means your source is set A, and then your target is also set A. Okay, so आपका target भी set A है. So you are going from A to A only. Now, what is the relation? Okay, so the relation is governed by this rule. Okay, so we are defining this. Now, the question is, can this relation be a function? Okay, guys, I'll pause here. So think about it. Do you think this relation can be a function? Okay, so let's understand this. Okay, so can this relation be a function? Okay, I think if you actually list down the ordered pairs, yeah, I think someone is saying something. Arsha, you wanted to say something? Okay, so anyway, so let's
No,
list
sir, I
down.
wasn't. Not me.
बेटा, I think the connection, Harsha, थोड़ा सा आज गड़बड़ है तुम्हारा connection, internet connection. Okay. But are you guys able to hear me okay? Om?
Yes, sir.
Okay.
sir.
Yeah,
Yes,
okay. So
sir.
let's continue. So is this relation a function? Okay. So now, if you actually list down the ordered pairs, okay, in the relation, you'll get an idea. So suppose I'll try to list them down. Okay. So if I take x as 1, suppose if I take x as 1, then I am expecting y 0. There itself I run into trouble. Okay, so I immediately run into trouble. Why do I run into trouble? There is no 0 in my target set because I am defining a relation on A. So when it comes to relation, I don't necessarily have to have, because ये रखने की जरूरत नहीं है relation में. Okay, so if I am not getting an element in the target set, which is used for a connection, for a relation it's okay. Relation के लिए I don't have that relation, that's it. So I'm perfectly fine. I can just move on and then say, okay, इसको हटा दो. I'll move to 2, and then I have 2 minus 1, 1. And then I move to 3. 3 minus 1 is 2. 4, 3. And 5, 4. I have a relation. So there is no problem with the relation. But the problem is, can this relation be a function? Okay, so it cannot be. Okay, no, this cannot be a function. But why? Why can't it be a function? If you look at both inputs and outputs belong to the same set, so that is understandable. Suppose x is 1, we just saw if x is 1, y is 1 minus 1, 0, and 0 does not belong to A. Okay, because 0 does not belong to A, you are taking A as the target set, you cannot make an association. So you cannot have that ordered pair in the relation, but for it to be a function, you must use all the inputs. Okay, आपका जो starting set है, that source set है, you must use all the elements. Here we are not using element, which is 1. The number 1 is not used. So this relation cannot be a function. Okay, so that is the idea. So one cannot have an output, hence this relation fails to get promoted to a function. Okay, so this cannot be a function. Let's take another example. So I have a relation from a natural number set to integers. Okay, so set of natural numbers to integers. So my source is, now here my source is natural number set. What did I write? Source, sorry. Source is 1, 2, 3, 4, and so on. Okay, so I have unlimited numbers. My target is this. Okay, so target is the integer set. So what do we have? There are many numbers now: -3, -2, -1, 0, 1, 2, 3, so forth. Okay, now what do I have? I have this rule. Okay, x is y square. Okay, so we have seen this example earlier. So your x is from the set of natural numbers, your y is from the set of integers. So when it comes to relation, your relation can be like 1 and 1, 1 and -1. Okay, and then you can have, let's say, if you have 4, for example, I can have with 2 connection, 4, I can have -2, and so on. Okay, so your relation will be a huge set. Here, pay attention here. So if you take 1, the same input is giving a different output. Sometimes it can be 1, it can be -1. For a relation, this is okay. There is no problem. But can this be a function? It cannot be a function. Okay, so you guys understand? So it cannot be a function, but why? If you look at those numbers, you will understand. So suppose x is 4.
Sir, I think Harsha left here actually.
Harsha left. What happened?
Yeah.
Okay, Om, you understand why this cannot be a function?
Yeah.
Okay, so here if you see your output, it has two values. So the second condition says that your input cannot have more than one output. It should have only one output. So that is why a single input cannot have multiple outputs. So hence this relation fails to get promoted to a function. Okay. Okay, I think I think Harsha is back. So we'll continue. Okay. So now let's take this relation. Again, this relation is from okay, so this relation is from n to n. Okay, so your source is the set of natural numbers, and then your target is also set of natural numbers. Okay, so you have all these numbers 1, 2, 3, and so on. Okay, now can this be a function, guys? What do you think? Can this relation be a function? Okay, so
Yes, sir,
what do you think?
since it has same image.
Harsha, what are you saying?
Yes, sir, it can be function since it has same image.
Very good. So it can be a function. Very good. Because you take any natural number, you get a square which is perfectly in the same set. Very good. So this can be a function. Yes, the answer is yes. So every natural number has a unique square. So hence this relation gets promoted to a function. Very good. Okay. Now, again, I know मतलब बहुत सारे definitions देखना पड़ रहा है. Okay, so this is another sort of definition kind of thing. Look at this. Real matlab you should think that we are looking at real numbers. Okay, so set of real numbers. एक real valued function है. Real valued function matlab the range is either the set of real numbers or a subset of real numbers. Okay, so this is just a definition that you need to keep in mind. Okay, so if you say that a function is a real valued function, आपका जो elements है output में, those elements should be either all the real numbers or maybe a part of the real numbers, a subset of the real numbers. ये आपको याद रखना पड़ेगा. Okay, and then here we are not saying anything about the domain. Domain कुछ भी हो सकता है. आपका range should be either real numbers or a subset of real numbers. Domain is neither necessarily the real numbers or nor it is a subset of real numbers. Then real valued function अलग चीज है. Real function थोड़ा सा मतलब meaning थोड़ा सा अलग है. Real, if you say a function is real function, then both domain and range must be real or a subset of real. Okay, so हम especially when we discuss things in physics. Okay, so physics में will be surprised आपको starting से ही थोड़ा basic calculus का use हो जाता है starting से ही. So आपको functions की understanding इतना deep भी जरूरत नहीं है, but starting में, but है तो अच्छा है. So there we mostly deal with real numbers. Okay, so in a way we can say that most of our functions are real functions there. Okay, so domain be either the real number set A or a subset of real numbers. Range is again the same thing. So definitions. So okay, so abhi ek symbol, naya symbol. Okay, so we have been looking at symbols. ये उल्टा V, I think it's like उल्टा A भी बोल सकते हो. V लिख के एक horizontal line. It means for all elements or for every element. Okay, so you can read this as for all or for every. Okay, so that is the meaning of this symbol, which we will be using in our function definitions here and there. Okay, it's not necessary that you use, Okay, you can write in English, but yeah, you might see this used. So it is a good idea for you to know about this. Okay, now we will take a look at a few types of functions. So this is an identity function. So identity function, maybe you can think is they will not change. Maybe your input is also the output. Some sort of an idea like that should pop up in your mind. Okay, so your identity function is this. Okay, so you are defining a function from the set of real numbers to the set of real numbers. So your identity function is a real function, and your input is x. So this is the way you write, guys. Okay, so this is something that you'll slowly understand. F of x is x, or if you want to write, you can write y. Instead of writing, let's say, f of x is x, you can also write y is equal to x, because most of the cases we take y to be our output and then x to be your input. Okay, वैसा रहने की जरूरत नहीं, but most of the case we do that, so we can say that. Okay, so this is the graph. I mean, if you take a look at the graph, takes few simple examples. Suppose if I take 1, x is 1, my y is also 1, right? If x is 1, my y is 1. Okay, so there is a point on that line. So my all these functions can be represented by graphs. Okay, so yahan par whenever we study functions, we make it a point that as far as possible, we will also get a graph, okay, in the xy coordinate system. So if you, again, these 1, 2, they're only specific values. When it comes to real numbers, between 1 and 2, there are unlimited number of numbers, right? Millions, zillions, like unlimited, infinite set. So 2 is connected with 2, 3 is connected with 2. Similarly, if you take something like 1.5, 1.5 is connected with 1.5. So whatever input that you give to this identity function, you will get the input as the output. Okay, so it is not doing much. So that is why this is the identity function. So yahan par, if you think about domain and range, so domain is the set of real numbers, and the range is also the set of real numbers. Okay, so I hope this is easy to follow. We'll move to another function.
Yes.
So this is a constant function. This is also easy, super easy. So the constant function should indicate that whatever may be the input, you're going to get the same output. Okay, because from function definition, it is okay for 2 or more inputs to have the same output. Okay, so ऐसा चलता है. Kind of ये बोल सकते हैं monopoly type से ये. Okay, so it's also a real function R to R, and then f of x is c. So c is some constant, okay, which is also a real number. And then if you look at the graph, I have taken a specific function. If f of x is 3, or you can write, if you like, you can write y is equal to 3 also. So you have a straight line which passes through 3 and then parallel to x-axis. So here domain is the set of real numbers, but range is only going to have that one element, c. So in this specific example, f of x is 3. Your range is just one element, singleton, which is 3. I think this should also be easy to understand. So we'll move on. Polynomial function. Okay, ये थोड़ा सा मतलब you studied polynomials, right? An example of polynomial is your quadratic function. Okay, ax square plus bx plus c. So now those things we will kind of study like functions. Okay, so basically, so y is equal to, you write it as ax square plus bx plus c. Now it has become a function. Okay, or if you want, you could actually write, instead of y, you could write f of x is ax square plus bx plus c. The degree is 2 here. Okay, so your polynomial function is again a real function from R to R. f of x is like a0 x plus a1 x plus a2 x. This is general, okay? General cheeze hum likh rahe hain. So again, here I have tried to use that symbol for all x belongs to the real numbers. You need to be careful here. In a polynomial function, the power of the variable, here we are having a single variable x. The power has to be non-negative integer. It has to be an integer, and that too a non-negative integer. ये आपको याद रखना पड़ेगा. Non-negative integer. So a0, a1, a2, they all belong to real numbers. Okay. I think I put one example. Okay. So here you have a polynomial. Okay. You might be wondering how I actually got this graph. Guys, I need to thank Desmos software for this. So I suggest you start using this software online. This is a fantastic one. It will help you understand functions better. Okay. So you can just type in any function. It is going to give you a graph. It will help you to understand. So are you familiar with Desmos?
Yes, sir.
You know Desmos. No? So you keep using, as we learn functions, use Desmos. Okay. So these are all plotted in Desmos. Okay. And this is also I've used this function because I was actually trying to solve this problem, and I mean I struggled actually. I took help from Sidhu to solve this problem. So once I understood the problem, I really liked it. So I'm using it here. Okay. So, but again, so starting mehi, you don't have to worry about the difficult polynomial functions. As an example, I'm providing here. Okay. So your domain is range, and then domain is range depends on the function definition. Okay, so we will have to see. Okay, so here it could be the real line, but we'll have to see. Okay, so few more examples. Okay, so if f of x is x square, or you can write y is x square, let's say. Then this is the graph. Okay, so it will be a parabola. Examples, let's take few examples. You can say few points. So 1 becomes 1 square, so that becomes 2. If you have 2, 2 becomes 2 square, so that is 4. Okay, so minus 1 will become 1. And then, guys, another thing is, whenever you have a graph, suppose, whenever you have a graph, by just looking at the graph, you can say whether this is a function or not. Okay, because you can graph things for anything, whether it is a function or not, you can graph it. But if a graph is a function or not, what you have to do is, there is something known as a vertical line test. Ye aage classes mein I will try to discuss these ideas and then do problems. There is something known as a vertical line test. So vertical line test tells you that if you draw a vertical line anywhere, it should cut the graph at only one point. Okay, it should cut the graph at only one point. So indicating that एक x value को अब एक ही y value मिल रहा है. Okay, so that is the test that you perform to figure out whether the graph represents a function or not. I will elaborate on this maybe in the coming classes on functions. But right now, we are just looking at simple functions. Okay, I think this is okay. Are we okay, guys?
Yes, sir.
Yeah. So let's look at few more. Okay, so again, यहाँ पर क्या लिखा है मैंने? Let's see that. Let me erase this. Go back. Are you able to see what did I type there? Note that the set after the right arrow. Okay, so whenever we have this definition, na guys, R to R, ये जो set है R, it is the codomain. Okay, so sometimes you may get confused कि R to R बोल रहे, but not all values are there. Okay, so this is just the codomain. For example, if you consider this same set, okay, so same function, you don't have any y values below 0. Okay, your y values are not negative because you have a square function. But you are saying you are mapping to R. So you are not trying to map to all elements in R. Okay, so you just have to keep in mind. So to the right of the arrow, whatever set we write, that is actually the codomain. Okay, it is not the range, it is the codomain. Okay, another function, f of x is x cube. Okay, so it looks something like this. Okay, so if you have y is equal to -1, it will be -1. Sorry, yeah, cube -1. Yeah, why am I getting confused? Yes, so y is equal to -2, then it will be, I think we can't see that, right? -2 ka cube kya hoga? -8. So it will be somewhere below. So similarly, and then so on. Okay, so it is aisa chad jata hai. This is like a steep upward curve hai ye. So x cube. And there are rational functions. Okay, so just say you studied rational numbers, right? Rational numbers are of the form p by q, and then p, q are integers, and then q should not be 0. Similarly, वैसे ही we have rational functions. Okay, so you have a function in the numerator, you have a function in the denominator, and the same criteria here. Okay, like you saw for rational numbers, the one which is in the denominator cannot be 0. Okay, so your g of x cannot be 0. So again, a definition, keep this in mind. Okay, so some more functions. So if you have f of x is equal to 1 over x, okay, so the graph looks something like this. Okay, so suppose your x value is very, very small. Okay, so x is like, if you take x is 0.5, okay, so what will happen to 1 over x? It will be 1 by 0.5. It can be written as 1 by 2, and then that becomes 2. So suppose if x is 0.01, okay, so your 1 by x will be 1 by 0.01, it will become 100. So suppose if your x is 0.001, what do you think your x will be? 1 over x will be 1,000. So as you get closer to 0, your y values are becoming very large. Okay, so your y values are becoming very large. And then as your x increases, because you are dividing 1 by that x, if your x is a very large number, the value of the function will become 0. Okay, and then similarly on the negative side also. So on the negative side, if you approach 0, it's a very large negative number. And then as you become like negative, more and more negative, it will become 0. Okay, again, see, these functions we will be using in the coming classes, but what I would suggest is like go through this session again. Okay, so play it again and then look at these functions. Okay, then this is a very important function, modulus function. Okay, or sometimes it is known as absolute function, absolute value function. These vertical bars have meaning. Okay, so these vertical bars have meaning. Okay, so you have to be very careful. So how does this look like? The function looks like this. What is it telling you is right now, whenever you look at mod x, you should understand it this way. Okay, so x mod x, you can write it as x minus 0. Okay, and then you keep this in mind. Okay, so it is basically distance of x coordinate. Okay, this is one meaning. It's a distance of x coordinate from origin. So आपका x coordinate can be negative. Okay, positive, negative कुछ भी हो सकता है. But ये function क्या कर रहा है? It is only giving you distance. Now distance से negative meaning, negative का value तो नहीं आएगा क्योंकि it's meaningless. So suppose for example, if you take x is 5, or if you take x is -5, and you're just looking at if you have mod of -5 or mod of +5, you're just trying to get the distance of this real number from the origin. That's it. Distance of this x coordinate from the origin. So distance तो 5 units का है. Okay, आप अगर +5 लो -5 लो फर्क नहीं पड़ता. So that is why this function will give you 5. Okay, for each of these, it is going to give you 5. Are we okay here? And then this can also be written a little differently. उसको क्या बोलते हैं ये? This is something that you will learn, guys. Okay, so this way of writing it is piecewise functions. मतलब pieces पे break करते हो, आपका function को pieces पे break करते हो. But break करने का criteria क्या है? आपका domain को break कर रहे हो. Okay, so आपका जो domain है ना, input space है, का source है, उसको break करके आप define कर रहे हो. This is called piecewise function definition. Okay, so piecewise function definition. So what is it saying? If your x is greater than or equal to 0, your f of x is x, right? So it doesn't, if you take, for example, your x is 3, so you get 3. Okay, but if your x is negative, then you're using a different function which is -x. मतलब अगर negative है तो it is getting opened up with a negative sign. So for example, if x is -3, what do? You are getting +3, right? Answer. So minus of -3. Okay, so minus of -3, it will become 3. Guys, this is a little new. Are you okay with this? Om, do you understand this function?
Yes, sir. Yeah.
Okay. Harsha, you're okay?
Yes, sir. I'm okay.
Okay. So again, this is a function which will be discussed in greater detail because very, very interesting problems can be formed on this modulus function. Okay, so we will see. Okay, very interesting problems. Okay. Okay, now this is signum function. Okay, so what is this signum function? So signum function is going to give you just 3 output values. Okay, so if your x is greater than 0, it's a real function, but output आपका only 3 values है. Okay, so kind of it is maybe working as a sign kind of thing. Okay, so it's only telling you some sign. So if x is greater than 0, you'll always get 1. Okay, if x is less than 0, you'll always get -1. If x is 0, 0. Okay, so that's what this is doing, signum function. So this is how the graph looks like. Okay, if you have any value greater than 0, your output will be 1. Okay, any value which is less than 0, output will be -1. If it is 0, it will be 0. So guys, here I'm using a closed, मतलब ऐसा dark circle जो है ना, it indicates that that point is included as part of the function value. ऐसा open circle draw करता हूँ तो it is not included. So that 1 when x is 0 is not correct. Okay, so when x is 0, it is 0. So ये भी एक definition है. इस पे भी अच्छे problems बनते हैं. We will see. Okay, we will see as we do, let's say, problem sessions. And this is another important function where questions आते हैं. Okay, so बहुत सारे अच्छे questions बनते हैं. Now, greatest integer function. So you have this closed bracket things, the square bracket thing. Now, what is this function is really telling you is, let's say if you take x, it is telling the greatest integer. Okay, so it's like greatest integer. It is going to give you greatest integer, which is less than or equal to x. Okay, so that is what it is giving. So we'll run through some examples. suppose I have x is 2, suppose if x is 2. This greatest integer function, sometimes they just call it GIF. Okay. Sometimes they call it GINT also. I think greatest integer bolte GINT. I think GINT is more popular. Okay. So GIF se zyada GINT, when short form में GINT ज़्यादा बोला जाता है. So if I take the input as 2, 2 itself is an integer. Okay, so less than or equal to में आपको 2 आ जाएगा. But if I suppose if I take 2.4, now 2.4 is not an integer, but this function is going to give me an integer. So if 2.4 is not an integer, it is going to look at the greatest integer, which is just less than that. So then it will give you 2. Okay, are we getting? So suppose if I have minus 2, it will give minus 2. Okay, but suppose if I have minus 2.4, what do I get if I have minus 2.4? Guys, what do you think I'll get with minus 2.4? What is that, Harsha? Minus 2? Okay, is minus 2 smaller than, what is that? Harsha, did you say minus 2 or minus 2? Minus 2 or minus 3?
Minus 2, sir.
Okay, is minus 2 smaller than minus 2.4? See, if you move more to the left, your numbers will become smaller, yes, right? Sir. So which is greater, minus 2 or minus 2.4?
Minus 2.
Minus 2 is greater, right?
Yeah, sir.
Okay, but we want smaller than minus 2.4, right? So what should this give you? You want an integer which is smaller. Okay, you need an integer which is smaller than minus 2.4. What will this be?
Minus 3.
It would be minus 3 only.
Yes, very good. It will be minus 3. You guys understand? Okay, yes. So anyway, don't worry, think about it. So you get like, if you graph it, you will get a step like this. Okay, so for example, if you see, if you have values from 0 to 1, 0 to 1, you will get 0 itself. Then immediately when it becomes 1, your input becomes 1, ये shoot हो जाएगा. So आपका 1 हो जाएगा. And then again, from 1 to 2, whatever values you take, आपका output 1 ही रहेगा. So you have, आपका graph looks like a step. So that is why this is also known as a step function. Okay, so this is known as a step function. So, okay, again, go through it, guys. I think after today, play this session and then look at it. On this function also, in the coming classes, we will see very interesting problems. Okay, so JEE में तो बहुत अच्छे problems बनते हैं, both absolute value function and then the greatest integer function. Okay, any questions here? Om?
No, sir.
No. Harsha, you're okay?
No.
Okay.
Yes, sir.
Yeah. Harsha, थोड़ा सा आज connection ठीक है. That's okay. So let's look at ये just definitions है. Okay, so you don't have to worry about these. Okay, addition of two real functions. जैसे हम real numbers को add करते हैं ना, वैसे ही हम real functions को add कर सकते हैं. So this is just, you have a function f and then you have another function g. These two are real functions. So the set x is a subset of real numbers. So if you add functions, okay, so f plus g, it is, you can just do whatever you are doing and then do whatever you're doing for both the functions. You can just add. Okay, so this I think we will see in examples. Should be easy to understand. So similarly, subtraction of a real function from another function. Okay, so same thing. So if you have f minus g of x, so you can do f of x first, and then you can do g of x. Okay, and then you can subtract. And multiplication of a real function by a scalar. This is again simple thing. So if you have a number, okay, this is a constant, and then you are multiplying that function, you can just keep it as a multiplier and then do whatever the function is doing. And once you get the value, you can multiply it. Okay. So this is again a simple thing. This is called algebra of functions. Okay. Multiplication bhi waisa hi hai. So f into g of x will be f of x into g of x. And similarly, quotient division. So f by g of x, f of x by g of x. And ये आप ध्यान में रखना पड़ेगा कि whenever you have anything in the denominator, obviously we don't want it to be zero. Okay, so चाहे वो function हो, कुछ भी real number हो, we don't want it to evaluate to zero. So आपका अगर f of x by g of x है rational, so g of x cannot be zero. ये आप दिमाग में रखो. Okay, guys, I think that's it for today.